All right. Welcome, everybody. Thank you for coming. Hi, everybody on Twitch. This one's out for you, not for anyone in here. Okay, so I am going to be talking today about how blocks work. Has anyone in here ever Rubied before? Have you ever slung codes out of Ruby script? Let me say it this way. Has anyone not written Ruby before? We've all written Ruby. If you've written Ruby or seen any Ruby, on day one, you probably saw a block. You may not have understood it, may still not understand it. They're one of those concepts that are, a little bit easy to see how they work, but a little bit more difficult to actually grasp how they function under the hood. So we're going to talk about what they are. I'm going to show them to you pretty soon. We're going to talk about and how they differ from other things that are like blocks, which hint for that is going to be procs and lambdas. So we'll save that for a little bit later. This is an intro talk. You don't have to know Ruby to follow along. There will be Ruby in here, but I think it'll be pretty intuitive. So let's get going. So how blocks work in Ruby by me. I'm Aaron Krauss. I'm the code boss. On Twitter, which I really don't use as much anymore. On Instagram, which I also don't use as much anymore. I'm on Reddit a little bit, so also the code boss. And I work for a company called Clevyr. That's this cool logo I have right here. I work with my two coworkers, Jesse and Jacob here, as well as 24, 25 other people. We are a software consulting shop in the city. We're about a mile north of Starspace. We work with a bunch of local clients. We've been growing a lot over the last 2 years. Just 2 years ago, we were about 7 to 10 people, so we've expanded quite a bit. Things are going great. But that's what we do. If you have any interest in that, talk to me afterwards, or these two guys here. I am also a board member of Techlahoma. And I also help John co-run this group here. So if you have any questions about how Techlahoma works, Kimberly Collins in the back is also a board member. Ask any one of us. Or if you want to get involved with volunteering, we've got a help wanted board, we've got a speakers wanted board. There's a lot that you can do, and we're always looking for volunteers. Techlahoma has grown dramatically over the last few years. And if we would, if you want to volunteer, we would love to have you. I guess I have that slide twice. I'm also, finally, a code.org volunteer. This is not Techlahoma related. This is not work related. This is a separate thing that you can go sign up for right here. And all that means is it's basically a school-based thing, a K through 12 thing. Teachers can find you. They can request you. You don't have to be a programmer. You can be just someone in the tech field. But the idea is that teachers will find you to basically request you to either come into their class to help out with anything. It could be helping out with an hour of code. It could be talking about what you do. That's kind of what I've done. Or you could just do a remote session. That's an option too. And by signing up to volunteer here, this is not an every week, every month thing. Honestly, I have not volunteered with code.org in probably almost a year. I don't get requests too often, but they sometimes go in spurts. But so you can deny it too. Like if you're busy, that's completely fine. But if you have an interest in volunteering, just with specifically in the school system, go check out code.org/volunteer. It's a lot of fun. It's very rewarding. So all that aside, now we can get to the real talk, which is my honeymoon to Japan. I went to Japan recently. I got married in December. That's why I was not here last month. It was because I was in Japan. Just having an awesome time. So that's what we're going to talk about today. We'll save the blocks talk for next month. So that's me in Tokyo with my beautiful wife in front of the Meiji Shrine. That's a torii gate behind us. That means we're about to enter the realm of the gods, the kami. It means it's a Shinto shrine. We're chilling out here in our ryokan. It's kind of a traditional Japanese inn. We're wearing yukatas there. They're like they're informal kimonos, if you will. Giant torii gateway and a little village right outside of Mount Fuji. We did get to see Mount Fuji. It was pretty bomb. That's Osaka Castle, kind of just in Osaka. That's where kind of the last famous samurai battle happened. That kind of ended that whole period. And Japan entered a peaceful time for a long time. This is the area of like 1,000 torii gates. You've probably seen pictures of this. Again, my beautiful wife Layla there. Cherry blossoms were about to bloom. This is in Kyoto there. So that's a big cherry blossom tree right there. And lastly, this is me with a bunch of deer in a town called Nara. Deer are sacred in Japan. And in this town specifically, they're not afraid of people because it's illegal to harm them. And they know when you have food. So just throughout the town, they come up to you. Anyway, this is me. This is my honeymoon to Japan. So we got that out of the way. I went to Japan. If you have any questions about that, hit me up as well. Back to reality. What are blocks? Well, blocks are there's a lot of things that they are, but the closest thing that they are a type of closure, if you will. And what's a closure? So closure, the most similar thing that you can relate it to that you've seen often is a function. So blocks are kind of like a function, just some group of code that executes. That's really what a closure is. But they're not functions, and that's a key thing to remember. Blocks behave like functions, but they're not functions. If you've never seen a block before, if you're new to this, we're gonna get into some code very soon. I'm just gonna get some of these kind of base definitions out of the way. They're core to how you use Ruby. They're actually a part of the syntax itself. Ruby has functions, and they have blocks, and they're different. They're syntactically different, and they are entirely different under the hood, but they behave in a similar manner, especially as you're learning them. So they're a part of the syntax itself. We're going to see that. You can use them in a variety of different ways. You can pass them around as function parameters. There's a little caveat to this, which we'll explain as we get deeper into this. You can use them as callbacks. So for my JavaScript developers, I know callbacks are your thing. I'm a JavaScript developer too, so I know all about that life. You would use them there. You use them in loops. That's probably one of the biggest differences where you would not use them in other languages. And you can use them as custom DSLs. A DSL is a domain-specific language. We're going to dig into that at the very end of this and just lightly touch on it. But a domain-specific language is just a way that you can use a tool to basically code a custom way to do things. It's a very vague term, but I've got a little demo at the end where we're going to show how you could use a block to do that. And that's just one of 1,000 ways to do them. DSLs they're not Ruby specific, but Ruby makes it very easy to do that, largely because of the ease of metaprogramming in Ruby. Not going to get into metaprogramming today, but we'll touch on DSLs at the very end. One important note is that almost everything in Ruby is an object, and I mean almost everything. Integers are an object in Ruby. Strings are an object. Obviously, if you have a class and you instantiate an object, that's an object. But classes are also objects. Again, we're not going to touch deep on these concepts, but almost everything in Ruby is an object. Blocks are not. About the only other thing that I know in Ruby that is not an object is a function, a method. Those are also not objects. But there are certain things that you can do on anything in Ruby, but you can't do on blocks. So let's get to a little demo and actually see how blocks work. So I've got about 16 very short demos here, and we're going to bulldoze through about half of them in the next 5 minutes. Again, they're very simple. So example 1 here. This is probably the first way as you're learning Ruby that you might see a block used. You've got an array of some sort, items. This has got 3 elements, 1, 2, 3. If anyone has issues seeing this in the back, let me know and I'll zoom in more. We're going to call the each function, each method on the items object, which is an array, and it accepts a block. Now, you can probably see what we're doing here. We're just going to put, that's just the print in Ruby, and we're printing out the item, and whenever we run this, we just get 1, 2, 3. It's exactly what you would expect. This is very similar to how the for each functions in C#, JavaScript as well. In those languages, especially JavaScript, you pass in a function, just swap it out here with a block, and you get that logic. The way this works is the each function on the class array accepts a block, and then it yields the next item to that block. That's a very important word. I just use yield. We're going to see that a lot here. So that's how we get this item here between these pipes, and then we can print it out this way. Again, this is how these are syntactically how you use blocks in Ruby. If you ever see do, you know you're inside of a block, and if you ever see these pipes, that means that you've got a series of parameters for that block. So first example of a block here. Let's hop to the next one. This is just another way to write it. I'm just going to bounce back and forth for a sec so you can see it. Just instead of using do and end, we've got our brackets here, curly brackets. Oftentimes the curly brackets are used for single line blocks. They don't have to be. You can expand this to multiple lines. That's just kind of the typical way you do them. But 2 ways to do blocks, exact same thing, 0 difference. Just this is one is syntactic sugar for the other. Okay. So let's say we wanted to build a function that accepts a block, like if we wanted to build that each function on class array. We're not going to do that, but we're going to do a simpler option and define a function called foo. We're just going to print out that we're in the method when we're in there, and we're going to yield. Now, again, that was the word I used earlier. What that means is that when we call this function, if we pass in a block, which we're doing down here, foo right here, that actually invokes the function. Remember in Ruby, we don't need to have the parentheses. We can do that, and it would work just the same, but we don't have to. So we're invoking the function foo, and we're passing in a block. And we're saying puts, now we're in the block. So as you might expect, we're going to yield to the block here. So whenever we run this script, we should print out this line here. We yield to the block, which then yields to this code here. Again, if you're familiar with the idea of passing a function around, this probably fits right into that. So let's run that. I didn't run the second example, but it should run the same as the first one. Okay, now we're in the method, now we're in the block. Okay, so again, just to review, we printed out the function here, yielded to the block, we did our thing. Bam. Let's hop on to a little bit deeper of an example. By default in blocks, just like Ruby functions, you don't explicitly have to put a return, and in blocks, you don't want to put a return. We're going to get to that. That's one of the little caveats of a block, but by default in Ruby, any closure, the last line of a closure will be the quote return statement of that closure. So even though we're not necessarily returning anything here, this last line here is just a string. That will actually be the return of the yield here, so then we're just going to print that out. So if we run this, we get the exact same thing that we did. We're in the method, now we're in the block. Again, I told you we're just going to bulldoze through about half of these. Now what happens if we yield to a block that doesn't exist? You see down here on line 4, we're invoking the function foo, and in that function we yield, but we don't have a block where we're passing in. What happens then? Well, you may expect this or you may not, but we're actually going to get an error, and it's a pretty explicit error, no block given. So if you are yielding to a block, you have to pass in a block. It's kind of like if you're missing a required parameter. Think of it that way. Now, what if there's a situation where you want to invoke a method, but you won't always have a block? You could argue that you could pass in a block that does nothing, but that's kind of weird as well. So Ruby has a nice, again, built into the syntax way of handling that, and it's this actual function called block given. That's part of the Ruby syntax. I did not import. That's just core Ruby. Now, also, if you're not familiar with Ruby, it might seem weird that we have this kind of question mark here. You might think that special characters might not be allowed on functions. In Ruby, that is okay. I believe there are some special characters that you can't use, but as far as exclamation points and question marks, those are fine. And the default is if you end a function in a question mark, that means it's a Boolean return. It's a function that returns a Boolean. So block given, ideally, it doesn't have to, but by convention, it should return either a true or a false. And again, in Ruby, if you're new, we can append if statements to the end. There's also an unless statement as well, which is just a negative if. Sometimes that can get confusing, but it exists. So we can do this. We can yield if a block is given, and here we're invoking the function twice down here. We're just going to invoke it once without a block and once with a block. So let's see what happens there. It's probably exactly what you expect, in that it works it doesn't error. It works. The first time we call it, we don't have a block, so we just puts this yield does not happen. And then the next time we call it, we do have a block, so we yield to the block. Okay. Additionally, kind of with the each statement, in our first example with that array each statement, I mentioned that it yielded each element to the block, and that's how we had that argument. You can yield arguments to the blocks as well, and you can yield any number of arguments. We've already shown you can yield nothing. Here we're yielding just the integer 3 if block given. And another thing we can do here, so we're invoking foo with a block, and that's just going to map to 3, right there. Count's going to be 3. We can put another block inside of there, so you can nest blocks, indefinitely. There's no problem with that. So again, count here is an integer, but again, we treat it just like an object because it is an object. So we're saying count.times, that's going to be a loop of 3 times because this variable is 3. And we're just going to print out now we're in the block. So we should print out we're in the method, and then we should print out now we're in the block 3 times when we run this. There we go. This will show that's the full line. I full screen that. That's everything. Printed it out 3 times. If we changed 3 to 6, it would print out 6 times. And we can yield, and again, anything we want to the block. We can even yield things that the block itself is not prepared to handle. So right here, we're yielding 3, and then we're yielding a string, and then we're yielding an empty hash. Again, hash in Ruby is the same thing as a dictionary in Python, associative array in PHP, the whole idea, just a key value store. But here in the actual block, we're only accepting count. And is this going to error? Is it not? You could argue that this is not great programming, but that's not the point here. it doesn't err. It's fine. So blocks themselves don't care how many arguments you pass. They don't check how many arguments they pass. Those are important things to remember that I'm going to pound into you that we're going to touch on later. So again, I've got some rules on blocks, and we're kind of done with the demos for now. We got about halfway through. Hop back to here. So some of the rules we kind of went through. Blocks can have any number of arguments. They can have none. They can have, I don't want to say infinity, but you get the idea. They don't check arguments. It doesn't require you to pass in a certain amount. It's kind of like JavaScript. JavaScript doesn't have function overloading. If you just pass in the wrong number of arguments, it'll still call the same function, and it'll just set them to nil or undefined, I suppose. A function can only accept one block, so that's something that I have not explicitly mentioned. Foo right now up here, we can't yield twice, and actually I have not tested that. I assume it would just yield to the same block again. So maybe I should say that we just can't yield to multiple blocks. We can't pass like foo, do this, foo, do this, do this, do this. We can't pass multiple things. So we're kind of limited to one closure in Ruby, if you will. Now in Ruby, and we're going to touch on this more, Ruby functions are not first-class citizens. What that means is that functions cannot be set to variables. So def foo, I can't set that to a variable as it is. I can't pass it around. I can't pass the function foo into another function as an argument. That's kind of the idea that blocks solve. Those are common things you can do in JavaScript and functional programming. In Ruby, functions are not first-class citizens, so you can't just pass them around. So that's kind of why we have blocks. And however you feel about that, it's okay, because we're gonna talk about it. A function can only accept one block, and blocks can be nested. We kind of showed that. One general rule we haven't learned yet, I kind of touched on this earlier, you should not return from a block. You'll notice that none of my blocks had return statements in here, and there's a valid reason for that. By default, in a block, if I return here, blocks are not functions. They're not going to, and functions are kind of the only place you can use a return. So if I put like return foo here, you would argue that it's not going to print anything because it would exit from this, and but it wouldn't error either. You could argue that this would be fine. Well, if I try to call that function, we're going to get an error, and that's because this is going to be weird, but I'm going to explain it. By default, when you invoke a block, if you explicitly return from it, it doesn't return back to where you're calling it, which would be somewhere in the each statement. It returns based on where the block actually is lexically in code. So it's trying to return from this scope right here, because we're calling the block at the root scope. So it's trying to return in the root scope, and the error is saying that we're basically just saying, return foo. That's what we're doing right here. And that probably just sounds like the strangest thing, but again, this is because blocks are not functions. When you return from a block, there's no call stack for them to go up to, because they don't behave that way. They're just going to return from wherever they physically are lexically in the code. So you could argue that's strange. My argument would be just don't use returns in blocks, or else you're going to come into some funny behavior. And this probably just sounds like a weird little fact I'm pointing out, but this is going to come into play a little bit later when we talk about procs and lambdas, which are other closures that you might use. So just kind of put that in the back of your head for now. Don't return from a block, and we'll touch more on that later. So why does all this exist? Why do blocks behave in this strange way? Why does Ruby even have blocks? Why don't they just have functions as first-class citizens? Why don't you pass them around like a quote normal language? Also, keep in mind, Ruby is not a new language. It's been around for almost 30 years at this point. So the things you might be used to in JavaScript just didn't exist when Ruby was a language. It was initially created, but many functional languages did. So the idea of passing a function, that was fine. That was established at that point. So why do blocks exist? And now we're kind of getting into there's no real answer. There's no real answer as to why Ruby behaves in this way. Mats has not, as far as I could tell, Mats, the original creator of Ruby, did not explicitly say, this is why I created blocks in this way. But this is kind of my idea behind them, and I like them a lot. And the reason I like them are because, let's get into my philosophy first. Regardless of what programming language you're using, if you're using a function that accepts a closure, so imagine you're passing a function to another function as a parameter, oftentimes you only need one closure. You're handling a callback, for example. When this button is clicked, do this logic. That's a common use case for the idea of passing a function to another function. Other options are you could think of map functions or filter functions or fold, which is also known as reduce or inject in Ruby. The idea of applying a function to an iterable, an array, for example, that only needs one function. Now, there's caveats to that, sure, which we're going to get into. But most of the time, when you need to pass a function to another function, you oftentimes only need one function. So, and this is my opinion, I think Ruby, and again, this is Matt's I'm talking about. I forget his full name, but Matsumoto is his last name. Matt's is just the abbreviation of that. Ruby decided to take that concept and make it super intuitive for new developers. And when I say new developers, I mean people who, so new Ruby developers, like, yay. When I say new developers, I mean developers who may not be used to the idea of passing functions around. There was a point in time when, I'm sure for many of us, myself included, that whole idea was just bizarre. Like, when I grew up coding, I learned, C++ and Java and a little bit of C#, and I'm sure a lot of us kind of went that path. And those things just don't happen that often. They can happen, absolutely, and they probably happen a lot behind the scenes, but the idea of passing functions around was not a super intuitive thing. So my opinion is that Ruby decided to take that idea of maybe you use a function just one time when you're invoking something, and wrapped a handful of syntactic sugar around that. And there are some really cool things you can do with blocks. So that's kind of my philosophy behind it. Again, I think this is awesome for new Ruby developers to go into code and see a block like this without really knowing the idea of maybe passing a function around. I can remember that when I first used JavaScript, maybe 6-7 years ago, the idea of just passing functions the way that it did it, especially with jQuery, for example, was just bizarre to me, and it was very difficult for me to wrap my head around it. It's very intuitive now, but there was a point in time when it was very difficult for me to grasp all of that. This, however, whether you know what's happening or not, this is relatively intuitive. If you just drink the Kool-Aid and say this is how I do this, then syntactically this makes a lot of sense. It's very succinct. It's Englishified, regardless of if you use this or the bracket syntax. But it's super intuitive to learn. And again, you can get very deep into blocks to where they do weird things like that return thing I mentioned. But as far as just on a surface level, I think blocks are incredibly intuitive for new developers. And I mean, new developers are also synonymous with new Ruby developers here. You can be an expert in other languages, but if you're new to Ruby, I think this is very powerful. But I know my JavaScript developers are there thinking, what about async behavior? Like, I pass callbacks in all the time because I need success handlers, I need error handlers, I need completion handlers, because my life as a JavaScript developer thrives on asynchronous behavior. And I fit into that role. I'm talking about myself there too. And I would argue that, wait, it's okay, because Ruby itself doesn't do async by default. The main Ruby implementation is called MRI, and it actually prevents you from doing asynchronous behavior. But just as a language itself, Ruby is very synchronous. So the way you would typically handle this behavior is just with a try-catch loop, something you're very familiar with, which in Ruby is begin, rescue, end. If you ever want to dig into kind of how a little bit deeper into how error handling works in Ruby, Xing Wang gave a good lightning talk about this a few months ago, and it's up on YouTube and Twitch, so check that out. It was phenomenal. But if you've never seen one before, this is just the standard error loop in Ruby. So begin, do the thing. If it succeeds, just do the code after that. That's not what I meant to do. If you have an error handler, then you do it here. So JavaScript developers are assuaged. We're at peace. But my functional developers out there, I think you saw the slide already, are just thinking, what's going on? Like, I need to be able to pass like 10 functions to another function, and then we just go from there. Obviously, that's a little bit. I'm being a little tongue-in-cheek there, but the idea of passing functions around in a functional language is how that language thrives. Haskell, Clojure with a J, Scala, Erlang, Elixir. All of those, they thrive on the idea of setting functions as first-class citizens, having functions as first-class citizens, so I can set them to a variable and passing them around. And my answer to that is I don't really have a great answer. You got me. Ruby is probably not your best choice if you want to do functional coding. You can do it, sure, and later on we're gonna talk about how you can do that using procs and lambdas. But just as a language as a whole, the way it's structured, it is not a functional first language. I would say it's certainly an object-oriented language. You can use it however you want to. It is multi-paradigm, but it is not. It's not going to be. You're not going to have a beginner using Ruby for functional programming. You're just not really going to see that. So like I mentioned, you can use procs and lambdas, which we're going to get into probably in the next 5 minutes. but it's not really a functional developer's best friend. There are other languages. If you know for a fact you want to go that paradigm, I love Ruby, but it's probably not your best choice. But if you do like Ruby and you want to go functional, I would encourage you to check out Elixir for that. There was a guy, I forget his name, but recently I say recently, but within the last year, gave a talk at the Oklahoma City functional group. What was it? Samiri? Okay, Samiri. Works at Osberg. Worked there at the time, I assume still does. Gave a great talk on Elixir. Elixir is a functional programming language that is heavily inspired by Python and Ruby, and it was actually created by a guy named Jose Balim, and he was originally a Ruby developer. He lived in Brazil. He created a company called Platformatic. Built a ton of tools when Rails was pretty fledgling, and he ended up becoming a core Rails developer for a while, and then struck out on his own to build the Elixir language, and that's gained a lot of traction. It's based on Erlang, so it uses Erlang, but it's phenomenal. There's a lot of activity. So if you want to go functional with Ruby, I would encourage you to check out Elixir. Syntax-wise, you're going to see a lot of similarities, but it's going to be a full-fledged functional programming language. So let's do some more demos now that we kind of know a little bit more about blocks and Ruby in general, the problems we're trying to solve. We're going to do a couple more demos. So let's see, we ended on 8 there, I think. Yes, so hop to 9. Okay, I'm going to full screen this so we can see this a little better. Oh, that was the end anyway. So what happens if we want to pass around a block? Right now we've just been yielding a block in the function that we're calling. So for example, foo is the function we've defined that accepts a block. We've just been yielding it in foo, but what if we wanted to pass that down the road somewhere? Maybe foo wants to call a function that then can invoke the block. How do we do that? It is possible. Well, what if I do this? What if I just call bar in there, and then in bar I try to call yield? Is that going to work? So let's try that. And the answer is no, it's not going to, because bar is going to be like, hey, you're calling yield, and there's no block. So we could do that whole if block given thing, but whoops, didn't mean to full screen that. But that doesn't solve the problem of the fact that the block did not get passed down into bar. So by default, if you are passing a block to a function like this, it's not going to keep following your stack. Nor should it. Like if I called a bunch of methods in foo, I don't want the block to be passed to every single one. So how do I get the block to bar? Like what is a block if it's not a first class thing? I can't really set it to a variable. That's another thing I haven't mentioned. You can't set a block to a variable. So it's kind of like functions in a way. It's not a first class citizen. In Ruby, how do I get it over to here? And there is a way. And it's gonna look pretty crazy, but let me hop to example 10. Nothing changed except that now we in foo we said that it's accepting a parameter, and it did accept this the entire time. We were just ignoring it. So again, this is kind of proof that in Ruby there's no function overloading. We're just we pass whatever arguments there are there. We have this ampersand block. Now that's a variable name. We could name this whatever we want to. I'm going to go back to what this ampersand means in a second. And then when we invoke bar, we're passing ampersand block to it. And then in bar is the same. We're just yielding. And let's just make sure this works before I explain it. It works. We're in the method, now we're in the block, and the block got yielded in bar, not in foo. So what's going on here? And this is going to be the end of this little demo, and we'll hop back to some slides. What's going on here? So when I call foo and then I pass in a block, the block actually gets sent as a parameter to foo. It gets sent as an argument so that the foo function can see it as a parameter. And this ampersand here does a very special thing. Blocks by themselves cannot be variables. You can't set them to things. But this ampersand will convert a block to a proc. So proc, we're finally going to talk about those. A proc is just an objectified version of a block. A proc is a block, but a proc is an object, but it can do very similar things to a block. It is basically a block that just has some object-orientedness wrapped around them. So you can set a variable equal to a proc, and you can use them. And that's this ampersand does that conversion. Now, if I want to use a block in here, I can just use a block like that. I don't have to do the ampersand. What the ampersand does down here is it converts the proc, which is currently, so block right now is a proc because we converted it to a proc up here. this proc is going to get converted back into a block, again with this ampersand, and that's why this function can stay the same. So we're yielding it, and we can't call yield on a proc. Yield is specifically a block thing. So just to review, again, foo, we're passing in a block. The block gets converted into a proc up here, which is what this block variable will be forevermore. And then when we pass this bar into, we pass this variable into bar, we're setting it as a block. And because it's a block, we don't have to set it as a parameter here. We just yield to it and treat it like a normal block. So that's what this ampersand does. That's one of the only reasons you will see the ampersand in Ruby. There are some other ways, some other reasons you would do it as well. And it gets into some syntax that even I don't 100% understand. I think Austin gave a great talk over I want to say ampersand syntax. Maybe it was a Lighten talk or so. Anyway, he would know better. Okay, so we've got our first introduction to procs, and we use them to pass blocks around. So what's a proc? Well, we kind of answered that. Proc is just an object version of a block. They're very similar to a block. They still have the same weird conditions that a block has, such as the return statement. We're going to touch more on that. I keep wanting to bring that up because it's just one of the weird things. It's very confusing, and I want to make sure I don't try to hide that from you. It's just a strange thing, but there is kind of a reason to it. So a proc is just a block that is objectified. It responds to the call method instead of yield. So if we want to invoke a proc, we just can't yield to it. We have to actually call a function on it, a method on it, and that's the call method. How about some of those demos? Let's see some demos of this proc in action. So let me close that. We just got too much going on here. Let's close out of that. Okay. So I'm on example 11 now. We've got our function foo. We've got our function bar. We're not passing around we actually don't have any blocks in here at all except for on this line down here. So let's step through this just step by step. These are just functions. I'll get more into these when we as we use them. We're defining a variable here, and we're creating a proc. So proc.new, and again, this is how you define an object in Ruby. Proc is a class here. And we're passing in a block here, and this is the only block we have in here. To define a proc, you still have to use a block. You have to use a block for a lot of things in Ruby. They're just part of how it works. And all this proc is going to do is just print out the statement, now we're in the block. And actually, I should probably say proc there. And then we're going to pass this proc as an actual function, as an actual argument in the foo function. It's no longer a block, so we actually have to say we're accepting this. If we don't, we can't use it. So foo is accepting a parameter, myProc, and we're just passing that again. This is just a normal variable. Imagine you're passing an integer or a string. It's just like that. We're dealing with first-class citizens here, no weird conversion type stuff. Bar accepts that, and then we're just going to call .call on it, and that's it. So let's see how that works. Let's clear that up. And it should work just like we have used the exact same, more or less exact, everything that should be working the same way as it has, except now we're in the proc, not the block. We could, I don't know if I do this later on, but we could, just like we yielded data to the block, we could say, we could yield something to the proc, and we could do, we could do that. Now we're not going to print it anywhere, but that should work just fine. So we could use X in that proc now, again, because that's not what I want to do. Because we're yielding that to that. I'm still going to use the word yielding it because I don't know what the right phrase for that would be. I guess you could say we're just invoking the proc with this argument. That might be better. But here's our first touch on how we are defining a proc ourselves. And if you need to, this is kind of Ruby's way of handling the fact that it can't do functions as first-class citizens. This is how you would handle that. If you need a situation where you need a function to accept multiple closures, that rules out the idea of using a block because you need multiple closures, then you could use something like a proc here. The only other option you have is a lambda, which we'll get into later, which behaves very similarly. But this is kind of how Ruby handles the idea of passing functions around, passing closure-type logic around. Oftentimes, if you use Ruby, you will get pretty familiar with the idea of procs, but it's interesting to see how not super common this is, whereas if you look at JavaScript, functions are flying everywhere. Obviously, if you're using a functional programming language, you see that all the time. In Ruby, you just don't see that very often, and I can't really explain why. It just isn't part of the language. don't know if it's a culture thing or if it's just kind of the synchronous nature of the language doesn't really require it, but whatever your opinion is, it just doesn't happen as much as you think it does. Let's hop to the next example. I need to full screen that again. Okay, so this is just an example that we can, okay, my editor did something funny there. There we go. Okay, so this is the same exact example as we were in, but now we're just converting a proc into a block again. So bar is kind of how it was originally. We're just going to yield to it. We're going to convert the same proc that we had and convert that into a block. So just kind of proof that this actually is how the flow works. So let's run that example. Same thing. We're in the method, now we're in the block. Everything works as expected. And let's see if okay, this is going to be the last demo before next little set of slides, and then we're almost done. This is kind of a representation. Here's a proc example, and notice how I'm using the return statement in here. This is going to be, remember that weirdness we saw kind of with the blocks way early on about if you return in a block, some weird behavior happens? Well, that happens in procs too. Now, this is another way you can define a proc in Ruby. There's a couple ways to do it. Same thing with lambdas. There's a couple ways. One of the last little code demos is going to show the different ways you can do everything. But this right here is just same as proc.new. And again, brackets are just another way to define a block. We're going to have this block, this proc accept 2 arguments, 2 parameters, and we're just going to return x times y, just simple math. So down here, we're going to invoke that proc. We're going to pass in 2 and 4, so this should return 8. And you would expect that it would return just in line here, to, right here. And then we would multiply it by 10, so we'd get 80, and then we'd return the result, and then we would, we're invoking the whole function here, so we should ideally get 80, would be kind of what I would expect. And I think a lot of you would expect that too. But when we get that, when we print this out, we get 8. And this is kind of where some odd behavior happens with blocks and procs. Now, this all goes back to procs behave very similar to blocks, and this is one of those ways. And you could argue that it's a very strange thing, but I would, again, remind you that blocks are not functions, so the idea of returning in a block, it kind of is a strange thing anyway. So because there's no function, it's just returning where the actual block is called, which in this case is the proc, and we're calling it right here. So even though we're returning inside of this closure right here, the actual return statement gets evaluated right here inside of this proc. So it's going to return from Proc Example this whole function, and that's why we get 8. So we actually don't even continue on this line here, and we definitely don't ever get to this line here. So as soon as we hit return in that proc, it just exits. And that's kind of the same weirdness you saw with the block earlier. Again, it's strange, I know, but that's the reasoning behind it, because blocks are not functions, and procs are pretty much just objectified blocks. They follow the same behavior. So let's talk about procs versus lambdas. Procs are a little bit weird, but they're kind of one of the only ways you can do functional development in Ruby if you want to go that route, or just passing functions or closures around. I keep saying passing functions. They're not functions, but passing the idea of a closure around, which most languages use as functions. So lambdas actually inherit from proc. They are a proc. It's just kind of a subclass under that. So lambdas are of the lambda class, but inherits from proc. So the same behaviors are all there, except there's 2 main differences. One of them, lambdas actually throw an argument error if the argument number doesn't match. Procs do not. You might remember way early on in this talk, we called a block with like 3. Here, I'll just kind of load it up here. I think it was, I want to say it was example 8 maybe. Yeah, so right here, we called a block with like 3 parameters, 3 arguments, and the block itself only accepted 1 parameter, and that was fine. It didn't error. Procs are like that too. We could call, whatever we wanted to. We could pass an incorrect number of arguments, and it would be fine. It would not error. Lambdas are not like that. Lambdas will throw an argument error, so it might behave more like you would expect. That's kind of the key phrase of lambdas. Like, lambdas are the proc that you think it works how it actually should work. So that's one thing. Lambdas will throw an argument error if you don't pass in the correct amount. And this is the big one. This is why I know that lambdas are kind of the better proc. At least, and I don't want to say better because there are different. There's reasons why they're different, but lambdas are the proc that you think That's how it works. So lambdas return in a local scope, whereas procs return from the scope in which they were called. What that means about procs is it returns wherever the actual proc was invoked, not inside of the closure of the proc. Lambdas return inside of the actual closure where they're defined, so they behave more like a function. So a demo is worth 1,000 words, but the reason behind this is because procs behave more like blocks. Lambdas, on the other hand, behave like methods or functions in Ruby, which is going to be what pretty much everyone is going to be familiar with here. Blocks are a Ruby-specific concept, so they behave a little bit differently, but lambdas are going to behave very much like how you would expect. So let's do our final demo. So we just kind of saw our proc example here and how it returned 8. Let's look at how we would do that same type of logic with the lambdas, and it's identical. We literally have the exact same code. I'm going to bounce back and forth just so you can see. We literally are changing this word proc to lambda, and that's it, aside from the method names. Everything is the exact same, so same thing happens. We're invoking the lambda using the same call, because again, lambdas inherit from proc, so call still works. We're passing 2 and 4, so we'll get 8 in this closure. We are still returning, and then we're going to multiply by 10, and then we get our result. So we got 8 when we did this with procs, but when we do it with lambdas, we get what you would expect, which is 80. So the return statement gets evaluated inside of this closure here, which is probably what most developers would expect, as opposed to outside here. Now, one caveat to note is that if I take out the return statement in both of these, then they are identical in this case. It's specifically because that return is there. Because remember, Ruby block does by default return the last line of a closure without needing the return statement. But without the return statement, it's kind of a soft return. The behavior is a little bit different. So now, if I saved all those, that still works. This is our lambda example. If we do 13, we get 80 as well. Again, because we're not using the return keyword. That's like one of the big differences between a proc and a lambda. Okay. This last one is not so much a demo. It's just kind of a showcase of the ways that you call procs. So early on in an example, you saw we did proc.new. That's completely valid. You've seen this keyword proc. That's just, again, one of this, I assume, is just syntactic sugar for this right here in Ruby. They do the exact same things. This is how we defined a lambda in that previous example. And this one we haven't seen yet, but this is just a little, some people call it a spiky arrow. Some people call it a lambda arrow. Whatever you want to call it, it's just a little shorthand for creating a lambda. So, and that's baked into the Ruby language as well. So if we just run that, we should get I'll full screen that. We should just get 2 procs, 2 lambdas. And all we did was invoke all of those procs and lambdas. So these are the different ways that you, that you can define procs and lambdas. You might see, you'll probably see all of these out in the wild, honestly. And then the last thing I was just going to show, we're done with the main comparison. You've kind of now got an idea of what a block, a proc, and a lambda are. I mentioned that I was going to show how you can use blocks for custom DSLs, domain-specific languages, and this is just the final thing. And this is just part of, I'm going to close that. This is something that I wrote for a company about 6-7 years ago. I was not necessarily new at Ruby, but it was a while ago. This does not actually execute because a lot of things are gone here. But I was building this tool that was supposed to, if you're on GitHub, for example, and you're editing a body, you can kind of create this checkbox thing by doing like the dash, and then it's this thing right here. And GitHub will actually create a checkbox. Well, that's not part of Markdown itself. GitHub actually added that. So I wanted to build a library to add that. And it gets a little more complicated than you would expect, because you go from being a Markdown renderer to like having to do like an update loop with a server. Anyway, all that aside, this is kind of my way of handling that. Whenever you're actually rendering your Markdown, you get the updated text, but then also you get this data object, which kind of, this is a Rails specific one. So again, this is Rails like 5-6 years ago. So I'm sure this may not work now, but I pass this object in, and this object accepts various properties on it. So this is kind of a very light example of a DSL where you can yield something to the block, and then you use that yielded object however you need to. It is a custom way that I've coded it to work. And I would obviously have to put this in documentation, like what does the data object have, etc. But this is kind of a light way that you can use a block to build the DSL in Ruby. Again, this is nothing complicated. There's many ways other languages can do this, but Ruby, you can take the DSL idea to significant layers more than this. But this is just a little demo on that. That's all the code I have. Kind of just to sum up procs versus lambdas, I think I've kind of gotten this point across a little bit already. If you need a proc or a lambda, I just recommend lambda. I think a lot of Ruby developers will, just because they will behave more like how you expect them to. Again, if you don't use explicit returns in your closures, then you really won't run into any problems. The only difference at that point is just that procs don't check arguments. Lambdas will throw an error. But it's one of those things where, especially if a new developer is going to use a return statement inside of a proc, then that's going to be a really tough conversation to have, because that's not an easy thing to understand. But those are the differences. I just recommend lambda, save yourself a headache, and they just behave more like you expect. So that brings this talk to a closure. Thank you, everybody. I am the code boss on various social medias that I don't check too often. I have the society.org website. I did buy the codeboss.dev. I just haven't set it up yet, so at some point I'll probably get that site up, and that'll become my main site. I work for Clevyr, and you can find more about us at clevyr.com. You can talk to me. You can talk to these two gents here as well. Again, that's my website. I used to be pretty good at blogging. I don't do it as much anymore, but I do put all my talks up there, so it kind of looks like I'm blogging, even though I'm not. And that's it. I've got questions. Pretty soon after 12:30, I've got to bounce because I've got a meeting. But we've got 7 to 10 minutes to just light me up with questions I don't know. Jonathan, yes. So you mentioned procs, or were you talking about blocks specifically?
Blocks. Like, how does it know? Like, here's this, it's not a function where it's like a policy. How does it know? Like, here's this chunk of code, go run it. Like, where is that sitting? Is it sitting in memory somewhere? Like, where?
Okay, so the question is, if I can repeat it correctly, is how do blocks necessarily exist if they're not on a function call stack? And what are they? Are they in memory somewhere? There certainly would be in memory. As far as the application stack itself, so not really a function call stack, but just a stack in general, like how whenever you run an application, how the stack goes, it would be in that stack somewhere, because that includes a bunch of stuff. But as far as how it exists otherwise, whenever it gets sent to a function, it just gets converted. It gets converted into a proc and used. I take it back. It gets sent as a block, and you have the option to convert it to a proc. So I don't know quite, other than just saying the generic, it's in memory somewhere. I don't know how that necessarily happens. I think that might be about as good of an answer as I can get. Yes, comment was use binding.pry, which is the kind of go-to Ruby command line debugger. Good comment, Ryan. Yeah, good question, John. Yes, awesome.
I have a question from Twitch. If you were using first class function, is that always use procs or lambdas, or do you often prefer blocks?
So the question was, if you're using functions as first-class citizens, is it bad to always use procs or lambdas, or should you use blocks as well? Neither option is bad. If you are defining a function that only accepts one closure, one function, if you will, no, closure is the right word, and it will always be that way, like a map function, for example, if you're defining something like that, it would be just culture-wise in Ruby, you would use a block, but if you were going to build something that you needed to accept multiple closures, then you have to use procs or lambdas, and you would probably never go the route of having a function accept both procs or lambdas and a block, unless they were drastically different in idea. Like if you're passing like two closures that don't do the same things but are similar in idea, then you would pass them as procs or lambdas. You wouldn't pass one proc or lambda and a block. And again, you can. There's no syntactic reason why you can't do that. It's just culture-wise, that would probably be a bad practice. You won't see that very often. But no, it is completely fine to kind of use either. Just kind of judge it on a use case. If you are just passing in one closure, then oftentimes a block is just going to be the more cleaner community way to go. Yes, Ryan. So the question is, when would you want multiple closures? Using Ruby, I really haven't run into that too often, and it's crazy to think that I'm saying that, because in other languages like JavaScript or just functional programming in general, especially when you get into functional programming, you've got the idea of currying, where you're splitting up a function multiple times. Those ideas, I've never really run across those in Ruby. I've really, honestly, I was a Ruby developer, like only Ruby, not even Rails, for 2 full years, and then about a Rails developer for the year after that. And I think it was very rare for me to ever use procs or lambdas. And again, that could have been the way that my organization was building things. Again, with Rails specifically, there are several manners in which a lambda does become preferable, such as if you have like a validates function and you want some additional logic there. But it sounds like you might be following up with something.
I was just curious, like, give me an example in the functional language of like common use, like actual use case for like multiple closures.
If you were in functional programming, let's see. I keep coming back to JavaScript coding with that, and just the idea of passing in multiple functions strictly for kind of asynchronous behavior. So that's kind of what my mind goes to by default. Yeah, success, failure, and then if you have kind of a completion logic after that. But more if your application expand, it kind of goes down 2 different routes, and for whatever reason, synchronous behavior is not an option, or it's just your language's kind of default option to handle that by passing in 2 closures. So I don't think that's a great answer. Did you particularly have anything? Okay.
I just was curious because I was trying to wrap my head around a common use case.
Yeah. Other than kind of just the asynchronous behavior that I've messed with many languages do have asynchronous behavior. Ruby by default is not great at it. There are other implementations that you can do that with, and at that point you would kind of spawn different threads. But beyond that, I think I'm just not as much of a functional developer to be able to answer that, because I'm sure that there are functional developers probably listening to this just screaming like, this is why you would need this, and this is why the reason that's why this whole paradigm exists. But yeah, I don't have a great answer. Yes, John.
Do you think things like begin rescue, like are those using blocks and procs good?
So does begin, rescue, end, which is Ruby's error handling flow, use blocks or procs? I've never, so to know that I would have had to look at the kind of core Ruby code, and I haven't, so it's all guessing. I would bet that it uses blocks, if anything. Especially, I don't know, and this is just a guess, I have no proof of this, but because they're such a core part of the language, procs and lambdas are, they're classes and everything as well, but begin, rescue, end is also a core part of the language, so I have a feeling everything there is very low level. So I imagine that you're probably just yielding the begin to a block, and then whenever you are, I don't know, catching the error, I don't know, because even exception handling is super low level, so I'm not sure. I can't give a good answer. My gut feeling would be that I bet it uses blocks especially to yield like the errors and everything, but I don't know that for sure. Good question. Alrighty. Well, we are at time, 12:30. Thank you everyone very much. You have some closing announcements, Jonathan? All right.
Can we give a hint for Aaron?